Hello out there, welcome to this tutorial on simultaneous equations. In this video, we'll be looking at equations with brackets and fractions. If you are joining us now, check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on simultaneous equations or systems of equations. So we start with problem 1. Solve 3 into 2x minus y equal to 2 into x plus y minus 1 and 3x minus y is equal to 4. So in our solution, we label each of the equations. So we have 3 into 2x minus 1 is equal to 2 into x plus y minus 2 as equation 1, and the second one, which is 3x minus y equal to 4 as equation 2. So for equation 1, that is from equation 1, we are going to expand the bracket and simplify. So we have 6x minus 3y is equal to 2x plus 2y minus 2. So we have 6x grouped together with 2x and negative 3y to be grouped together with this. So bringing this 2x to the left hand side, we will now be left with 6x minus 2x, because as it is coming, it changes to negative. So we still have our minus 3y here, this plus 2y coming to the left hand side, it becomes minus 2y, then equal to negative 2, which is the only term that is left at the right hand side. So this is giving us 4x minus 5y is equal to negative 2. Then we call this one equation 3. So we're going to look at equation 3 and 2 and solve them together. So if we look at this, we want to eliminate y. Therefore, we just multiply equation 2 by 5. So equation 2 multiplied by 5, we are going to have it as 15x minus 5y is equal to 20, and that is multiplying by 5. So we call it equation 4. Now we are going to subtract equation 3 and 4 in order to eliminate y. Since we have minus 5y and minus 5y here, so we go ahead and say equation 4 minus equation 3. So this is equation 4 minus equation 3. So 15x minus 4x gives 11x. This will be gone. So 20 minus negative 2 will give us 20 plus 2, which gives 22. Dividing both sides by 11 because of the coefficient of x here being 11. So x is equal to 2. So from here we substitute x is equal to 2 in any of the equation. So we are putting x is equal to 2 in equation 2. So we have it here. That is going to give us 3 into 2 minus y is equal to 4. So if you take this to this side and bring this to this side, you'll be left with y equal to 6 minus 4. So here we now have y equal to 2. And the solution in coordinates form will be 2, 2, where x is 2 and y is 2. That's the end of solution to the problem represented in problem 1. So we are done with that problem. We go to problem 2. For problem 2, solve these simultaneously. 5 into x plus y is equal to 3 into 3x minus 2y plus 1, and 3 into x minus 2y is equal to 4 into 2x plus y minus 5. Again, we have two equations here. So in our solution, we are going to have the first equation and label it as equation 1. then the second equation, and label it equation 2. We then expand the brackets and simplify. So from equation 1, we are going to multiply 5 by every term in the bracket. So we have 5x plus 5y. This is going to be equal to 9x minus 6y plus 3. So we collect the like terms. For information, the sides can be interchanged. So we can have it as 9x minus 5x is equal to negative 6y minus 5y is equal to negative 3. So I've taken this to this side and brought the whole to this side, then interchanged the sides. So this is going to give us 4x minus 11y is equal to negative 3. So we call this one equation 3. We now go to equation 2. So from equation 2, we have 3x minus 6y is equal to 8x. This is plus 4y, then minus 20. That is, we have expanded, we collect the like terms. In the same way, we have it as 8x minus 3x plus 4y, then plus 6y is equal to 20. So what we did here is the same we are doing here. This is going to give us 5x plus 10y is equal to 20. I can divide through by 5, so I have x plus 2y is equal to 4. So dividing each term by 5. So we call this one equation 4. Then we look at equation 3 and 4. Going by elimination method, we have 4x here, we have x here, we have negative 11y and positive 2y here. So it is very easy for me to multiply equation 4 by 4. So that will now become 4x plus 8y is equal to 16. Then I call it equation 5. Then what do we do? Is it addition or subtraction? This is 4x, 4x, so it's subtraction. So we now say 5 minus 3. This equation 5 minus equation 3. Equation 5 minus equation 3. So 4x minus 4x is gone. So 8y minus negative 11y is going to give us 19y. 16 minus negative 3 gives plus 19. So we have 19y is equal to 19 and y is equal to 1 after dividing both sides by 19. So we now go ahead to substitute y is equal to 1 in any of the equation. But in this problem, we are picking equation 4. So we say, wherever we see y, we put 1. So we have x plus 2 into 1 is equal to 4. So we've done that. Then we now leave this here, take this to the other side. X is equal to 4 minus 2. After taking this to the right hand side, where x is equal to 2. So in coordinate form, we have 2, 1, that is x, y. So we are done with problem 2. Then we go to problem 3. For problem 3, solve the pair of equations simultaneously. So we have x plus 2y over 3 is equal to 1 whole number 5 over 6 and 4x minus 3y all over 2 plus 2 is equal to 0. So what we do now, again, we label each of the equations. So before then, we are going to have it as x plus 2y over 3 is equal to 11 over 6. I have changed this to improper fraction. 6 times 1 gives 6. 6 plus 5 gives 11. So we have it as 11 over 6. Name it equation 1. Then the second equation now will be formed by 4x minus 3y over 2 is equal to negative 2. I've taken this positive 2 to the right hand side, which will automatically change to negative. So we call that one equation 2. So now what we do is to remove fractions from the two equations. So starting from equation 1, the LCM of the denominators, which are 3 and 6, is 6. So we multiply each of the terms of the equation by 6, which is the LCM. So 6 times x gives 6x. 2y times 6 over 3 gives 4y and is equal to 11. I hope you know how we got 4y from here. If you multiply by 6, 6 divided by 3 gives 2. That 2 multiplied by 2y gives 4y. And we call this one equation 3. So from equation 2, it is as good as cross multiplying. So we still have our numerator as 4x minus 3y is equal to negative 4. That is multiplying this negative 2 by this 2. We have negative 4. This is equation 4. And now we want to eliminate x. We want to eliminate x. If I multiply this by 2, I get 12. This by 3, I get 12. So we say equation 3 multiplied by 2 and equation 4 multiplied by 3. So this is going to give us, from equation 3 now, we have 12x plus 8y is equal to 22. Then I call that one equation 5. Here, multiplying by 3, I have from equation 4, 12x minus 9y is equal to negative 12. Call this one equation 6. So what we do now is we are concentrating on equation 5 and 6. Then what operation we eliminate x? So we say equation 6 minus 5. 12x minus 12x, x is gone. Minus 9y minus 8y gives negative 17y is equal to negative 12 minus 22 gives negative 34. So dividing both sides by negative 17, y is equal to 2. So having done that, we put y is equal to 2 in equation 3. So here is equation 3. Wherever you see y, you put 2. So we have 6x plus 4 into 2 is equal to 11. So we now have 6x is equal to 11 minus 8, where 6x is equal to 3. Dividing both sides by 6, x is 3 over 6, and this is not in the simplest form. So in simplest form, we have it as 1 over 2. So that is it. So we now have it in coordinate form as 1 over 2, comma 2. So that's all for the solution of problem 3. Then we go to problem 4. For problem 4, we have to solve 2 into a minus 2b all over 3 is equal to 5a plus b all over 6 plus 1. And 3a plus 2b is equal to 7 simultaneously. So in our solution, since this is the only one that has fraction, I can deal with it first, remove the fraction and the brackets, simplify and label it equation 1, then bring this one directly as equation 2. So starting from that, now to remove the bracket, we have to multiply each by the LCM of 3 and 6, which is 6. So multiplying this, we are going to have it as 4 into a minus 2b is equal to 5a plus b plus 6. 1 times 6. Then expand this bracket. This is 4a minus 8b is equal to 5a plus b plus 6. So collecting the like terms and bringing this to this side. So I have 4a minus 5a, then minus 8b minus b is equal to 6. This is negative a minus 9b is equal to 6. I want to remove this minus, so by multiplying each of the terms by negative 1, so I'm going to have it as a plus 9b is equal to negative 6. So I call this one equation 1, then I bring down these, so I call this equation 2. Now we check the coefficients. For a, this is 3a and a, this is 9b and 2b. So we can easily multiply equation 1 by 3 to make the coefficient the same. So equation 1 times 3 gives 3a plus 27b is equal to negative 18. Call it equation 3. Then we now simplify equation 2 and 3. So we said 3 minus 2, equation 3 minus equation 2. So that's going to give us 3a minus 3a, 0. 27b minus 2b gives 25b. This is equal to negative 18 minus 7 gives negative 25. So dividing both sides by 25, we have b is equal to negative 1. And that's all for b. We go ahead to substitute b is equal to negative 1 in any of the 3 equations. So we are picking equation 1. So we put b equal to negative 1 in equation 1. So we have a plus 9 into negative 1 is equal to negative 6. So this is negative 9 going to the other side. So we have a is equal to negative 6 plus 9. Since 9 times negative 1 gives negative 9, going to the other side, it becomes positive. So a is equal to 3. And in coordinate form, we have 3, negative 1. And that's the end of solution to problem 4. We go to problem 5. For problem 5, we have to solve 3 over x plus 2 over y is equal to 5 over x minus 2 over y equal to 4. So you can see all of them, this equal to this equal to this. We are going to form a pair of simultaneous equations. So in our solution, we pick these first 2 terms, equate it to 4, and these 2 terms also equate to 4. So we have a 3 over x plus 2 over y is equal to 4, call it equation 1. Then the last 2 here, we have 5 over x minus 2 over y is equal to 4, forming equation 2. Then from equation 1, we want to remove the fractions. We multiply through by the LCM, and the LCM is xy. So 3 over x times xy, so the x will go. We'll be left with 3y, so we have 3y. 2 over y times xy, the y will go, we'll be left with plus 2x is equal to 4xy, and this is equation 3. Then from equation 2, we are multiplying each of the terms by the same LCM, which is xy. So here we are going to have 5y minus 2x is equal to 4xy. We call that one equation 4. Then the coefficients of x is the same for 3 and 4 but different signs. So which means we are going to be adding equations 3 and 4. So we say equation 3 plus equation 4. So 3y plus 5y gives 8y. This will be gone. That's going to give us equal to 8xy. 4xy plus 4xy. So first divide both sides by y. So we have 8x is equal to 8. And finally dividing both sides by 8, we have x is equal to 1. Then we put x is equal to 1 in equation 3. So wherever you see x, you put 1. So you have 3y plus 2 into 1 is equal to 4 into 1y. So these are the terms with y now. So this is 4y. Bring this to this side. I have 4y minus 3y is equal to 2. This is giving us y is equal to 2. And in coordinate form, we have it as 1, 2. That's the end of solution to problem 5. This is the highest we can take in this tutorial. I hope you enjoyed it. Please like and share this video. Remember to subscribe to our YouTube channel if you have not done that. Also check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on simultaneous equations and systems of equations. Until we come your way again, goodbye.